This is all of it. Not the endure. Pues que ya ni se le da.
Okugiparkinga obulungi kwe kuti. I'm about to begin the lesson, so Kende's okwogerako. Okugiparkinga obulungi kwe kutya. Sinaba, if I'm still talking to you, have not yet. Andikewo enamba bagisangewo. A moving vehicle. Good morning, guys. Sorry. Sorry. Good evening, guys.
Good evening, teacher.
Yeah, sorry. I was a little bit picked up by traffic, but I'm here. I have some two special numbers I'm going to dictate now. Before I can go for our numbers, I have to do that number for the proof. So there is this number I've just written here, which says a moving vehicle with uniform acceleration covers 5.5 meters within the 4th second and 9.5 meters within the 8th second. The 4th second, between 0 and 1 is the 1st second. Then between 1 and 2 is the 2nd second. Then between 2 and 3 is the 3rd second. Then between 3 and 4, this is the 4th what? Second. Likewise, between 7 and 8 is the 8th what? Second. So the first between 0 and 1, the second between 1 and 2, so the 8th will be between 7 and 8 seconds, whereby this will be the time, then this will be the position of the time, whether first time, second time, third time, and all that, and so on and so forth. Now, we need to be very sensitive. When they give you anything second, let me mention something brief about this. Distance covered. Distance covered in the nth second. Distance covered in the nth second is got from distance when time is n minus the distance when time is n minus 1. That is the distance covered in the distance covered in the nth second. That means you take the distance of that n talked about and the distance of the time before n less by 1. So if they say 8th second, it means to get this distance, you look for the distance when time is 8 and look for the distance when time is 7. When they say 4th second, you look for the distance when time is 4 minus the distance when time is 3. That's when you get the distance between the 4th second or the 8th second. So this is the distance in the nth what? Nth second. So with that reason, can we look at our question? They have said the distance covered in the 4th second is 5.5. Then the distance covered in the 8th second is 9.5. So what does that mean? It means the distance when time is 4 minus the distance when time is 3 is equal to the distance, which is 5.5 meters. That is equation 1. While for the second case, they have said the distance when time is 8 minus the distance when time is 7 is equal to 9.5 meters. So with that distance, we need to go to the equation for distance, which is S in terms of time is UT plus R half AT what? Squared. So I'm going to use the second equation of motion because the second equation of motion has time and it has initial velocity, which they want us to find, and it also has acceleration. Now, distance in the 8th second will be equal to initial velocity times 8 plus R half times acceleration times 8 squared. This will give me 8U plus R half times 64A. When you divide 64 by 2, you get 32. So this gives us S of 8 is equal to 8U plus 32A. Equation 3. With this, I can also get time, distance when time is 7. So distance when time is 7 will be 7U plus R half times acceleration times 7 what? Squared. This will give me S of 7 is 7U plus R half, which is going to be 24.5 of A. This is equation 4. How did I get 24.5? 7 squared is 49. 49 divided by 2, you get 24.5. Now, the question said the distance in the 8th second is 8 minus distance when time is 7, and that distance was 9.5. So subtract equation 3 minus equation 4. You will get 8U minus 7U plus 32A minus 24.5A. That difference should give you 9.5. With this, you get U a plus 32 minus 24.5, that is 5.5, you get 7.5. A is equal to 9.5. Let me call this equation star 1. So I've designed an equation in terms of U and A and a value of 9.5. Okay. Someone having a question on the chat? So pardon on the time thing. Okay. I was saying we get time in the nth second. You know, most of you have wrong ages. If you're born in 1990 and 1991 January it clocks, you were born in 1990 January, this is your first year. When you come to 2000, yeah, 2000 to 2001, you will be in which year? You will be in your 21st year. That means that is the period which is going to give you 21 years after the end of it. But before the end of it, you're not yet 21 years. Now, when they ask for nth second, distance covered in the nth second, it is the distance when time is n and the distance before that n. When time is before that n, the time before that n is n minus 1. So the difference between those distances will give you the distance in the nth second. Now, here when they say time or distance covered in the 30 second, it means you cover distance, look for distance of time is 3, and distance of time is 4. Then you subtract, you will get the distance in the 4th what? Second. Having seen that, can I now go for the other ones, which is for 5.5? We have S of 4, which is equal to 4U plus a half times A times 16. So S of 4 will give us 4U a plus 8A, equation 5. Then distance of 3 shall be 3U plus a half times A times 3 times 3 squared is 9. By 2 ones, by 2, 4.5. So distance of 3 shall give me 3U plus 4.5A. And this will be the 6th equation. So I can subtract equation what? Equation 5 minus equation 6. I'll get 4U minus 3U, you get 1U. 8A minus 4.5A, you get 3.5A. The difference between the two should give us 5.5. So this is 5.5, and this is my start 2. Finally, I have my 2 concrete equations to solve. Now I'm bringing back O-level solving. Don't use matrix, you might cause problems. You can make an atomic bomb when you're solving using matrix. So we can solve by elimination. Start 2 minus star 1, which is 7.5 minus 3.5, we get 4A plus 0 is equal to 9.5 minus 5.5. 9.5 minus 5.5, we get 4. So 4A is equal to 4. My acceleration is 1 meter per second squared. Furthermore, I can substitute this acceleration back to find the initial velocity in stars. So I'll have U plus 3.5 is equal to 5.5. So U shall give me 5.5 minus 3.5. U is equal to 2.0 meters per second. So the initial velocity was 2.
Excuse me, teacher.
The acceleration was 5. Yes, please.
Can you please repeat how you got the 5? Okay, like how you got the acceleration.
Hey, the acceleration, I've got it by subtracting this equation. You see this equation here? Yeah?
Yes.
It was subtracted by, we subtracted off. It was, this is star 2. Star 1. Hey, I've written the wrong directive. It was supposed to be, it was supposed to be, star 1 minus star 2. Does it make it clear now? U minus U, 0. 7.5 minus 3.5, you get 4A. Lastly, 9.5 minus 5.5, you get 4. So we can have that down, no questions.
Yes, thank you, teacher.
Anytime.
Excuse me, teacher.
Yes, please.
So I'm sorry for taking you back, but I'm wondering, what's the nth second?
Hey, nth second is the it's time it's the time in the nth second. I gave you an illustration of something like this. When do we have the first second? The first second occurs when time is starting from 0 up to 1. From t is 0 to t is 1, you are within the first what? Second. So from here, that's why you have microseconds. 0.01, 0.02, 0.03, up to when you reach what? 60. When you reach 60 microseconds, you get time is equal to 1 second. Then you add on to get time is 2. Here you will be within the second what? Second. Now when you come to n, if n is here, then the time before n is n minus 1. So to get the time between n and n minus 1, you are getting time within the nth what? Second. Okay? So if you're getting time within the nth second, you use time when use time difference and get the distance when time is n, and get the distance when time is n minus 1. When you get those distances and you subtract them, you would have attained the distance for the nth what? Second. Is it clear now?
Yes, teacher. Thank you very much.
Anytime. Someone is sending a chat. Guys, it's better you unmute your mic and ask your question. It is faster for response than the chat. We have another question. If I can go to the questions I sent you. This one says 2 particles are traveling in a straight line of length 35 meters. At the same time, one particle starts from rest at A and travels towards B with a constant acceleration of 3 meters per second squared. The other starts from A towards B with a constant acceleration of 6 meters per second squared. Find when and how far from A the particles collide. Okay. With this, we are saying we have point A, point B. These points are 35 what? Meters apart. At point A, the particle starts from rest. So initial velocity is 0. The acceleration is 3 meters per second squared. And travels towards B, the constant acceleration. The other particle starts from one particle starts from rest, and the other starts from B. Should be. The other particle starts from A towards it. One particle starts from A at rest and travels. No, the other one starts from B towards A. With an acceleration of 6 meters per second squared. Because it starts from B, U is 0. Now, when they travel, they might collide here. If A has moved X so far, let me change the color. If A has so far moved up to X, then the distance here left is 35 minus X. So this one to collide would have moved the distance of 35 minus X, while this one to collide would have moved the distance of X. So the distance of A is equal to X. Then the distance S of B shall be 35 minus what? X. But since they began at the same time, the time they take T is the same. So if they take time T, which is the same, let me put it up here. The distance for A is equal to UT plus a half AT squared. The distance for A is X is equal to the initial velocity is 0 plus a half times 3 times T squared, giving me 2X is equal to 3T squared, equation 1. Then for distance for B is 35 minus X. 35 minus X shall give us UT for B plus a half acceleration for B. The time is the same. So 35 minus X is equal to 0, because the initial velocity at B is also 0, plus a half times 6 times T squared by 6 once by 6 3. Therefore, 3T squared is equal to 35 minus X. So having realized that, I can solve equation 1 and 2 together. According to this one, X is 3 over 2. X is 3 over 2 T squared, or 1.5 T squared. So drop the X here, you will get 3T squared is equal to 35 minus 1.5 T squared. This will give me 1.5 T squared is equal to 35. Sorry, plus 3T squared is equal to 35. I have brought this one this way. Becomes a plus. So I get 4.5 T squared is equal to 35. 4.5 comes from 9 out of 2. So 9 T squared over 2 is equal to 35. So T squared is equal to 70 over 9. Tushime, can you give us the answer? What's T? Tushime, please give us the value of T.
Sure. It is 7.8 actually.
Eh? For the small places, this is applied math.
7 point. But 7.7 is 7.8.
7.778. That's all.
7.
Teacher, that's for T squared, not T.
Get me the square root also.
It is 2.7889.
2 point.
2.78.
2.7829. If you are not sure, you let it be root 9. You get root 70 over 3. If you are not sure, eh?
Excuse me, teacher.
Yes, please.
0.7889.
Yeah, it's 0.7889.
889, eh?
Yes.
Yes.
9 what?
2.7889.
Only. Now substitute
Yes.
back here to get x. X is equal to 70 over 9 times 3 divided by 2. Here once, here 3. Here once, 35. 35 divided by 2, you get 11.667 recurrent. True?
$35 divided by 3 is 11.6667.
Which is correct. Okay?
Yeah.
Okay, so that is the situation when bodies are going to collide and they're moving along the same straight line, and you need equations of what? Motion. So you can have that down. Then there is that number for the proof, which I'm going to do. You have it in the questions from Humphrey.
Excuse me, teacher.
Please go ahead.
Is uniform acceleration the same as constant acceleration?
Yes, please. It means A does not change. Okay?
Teacher,
Teacher,
Yes, please.
teacher, I would like to know if at all I get I do something on the calculator and I get many decimal places. If I write the exact things on the calculator, will I be penalized?
Beyond the 4 decimal places or less? Are you writing everything as it is beyond the 4 decimal places or less?
I'm writing everything as it is beyond 4
Everything as
decimal
it
places.
is, you'll be given marks. But why would you write everything? All the 10 digits. The maximum is,
Yes.
the minimum is 4. When they have not told you maybe 5 significant figures, 3 significant figures, 4 significant figures, 2 significant figures, if that statement is open, it has no such wording, then you write up to 4 decimal what? Places. Okay?
Yes, teacher.
Yeah. But if they specify to 2 significant figures, for example, 11.6, the first significant figure is 1, the second one is 1. They say 2 significant figures. Yeah? So you can round it off to 12. If they say 3 significant figures, you stop here, but you round this to 7. This one was 2.889. 9. If they say 3 significant figures, 2.2 is a significant figure, 8 is a significant figure, this 8 is also significant. So you round it off to 289. So when the question comes with such comments, please remind it. Or 2 decimal places, then maintain the 2 decimal places by rounding off. 3 decimal places, cut the 4 to 3, and so on and so forth. Do you all have that number? You know my WhatsApp restored by itself. Now I don't have messages I sent before. Well, let me try to take a picture here. Oh, but I have the picture.
Show which number?
The one for the proof. I want to send it to the group. That's number 27. So there it goes. It reads, a particle is moving in a straight line. This is the number. And is observed to be at a distance A from a marked point initially. Hear that statement. The particle travels in a straight line. Initially, it is observed to be away from a particle, to be a distance small a from a marked point initially. So here it is at a distance small a. Let me call this point capital A. Then to be a distance small b after an interval of any seconds. Now it is here at position B. At B, it has covered a distance of small b. But in how much time? In a time which is n what? Seconds. To be a distance small c after 2n seconds. It is at position C, and it has now covered a distance of what? Small c up to where? Up to there. How much time has it taken? It has taken a time from here up to there, which time is 2n. Then to be a distance, at a distance small d after 3n seconds. Now, from this origin point O, it is a distance small d, and it has taken how long, how much time? It has taken 3n seconds. So the time from here is 3n up to there, where I have position D. Now, the special bit about this is, eyes open very well. It was initially a distance A away from the marked point O. But when it started moving, it covered time n. So it moved from A to B. What distance did it cover? Guys, what do you think? What distance did it cover from A to B? Girls, what distance did it cover from A to B? You see this
B
distance?
minus A.
It is going to be B minus A, correct. Then, how about from A to C? What distance is it intending to cover? From A to C.
C minus
C
B.
minus A.
C minus what? A. Then lastly, from D, from A to D, what distance have we covered?
D minus A.
D minus A. If you identify that distance correctly, the times are steady, they are continuous, they are obvious. Yeah? So it means we can use the second equation of motion, where S is equal to UT plus a half AT squared. So the distance between A and B, that distance is B minus what? A. So
Teacher, may you repeat?
we said,
My network was poor.
okay, sorry. We have said the particle is moving in a straight line and is observed to be a distance small a away from a marked point O. This is the marked point O. Then from this marked point, to be a distance small a away, I'm assuming small a is at position A. Now from A, it moves for n seconds to reach a point B. But at that point B, it will be a distance of smaller b from the marked point O. Then when it moves again in the next 2n seconds, it would have covered a distance up to point C. But from point C to the marked point O, the particle would have moved the distance of C minus A. Because we are counting its movement from A. Then lastly, from A to a point D, the particle would have moved the distance of D minus A, and time covered would be 3n. And with that, it would have covered a distance of D minus A. So with those distances and times, we are good to formulating equations to solve simultaneously. And to start with, I'm looking at the distance between A and B, which is B minus A. We assume it's began with the initial velocity U. It is moving in a straight line with an acceleration F. So let F be the acceleration. Do not use A this time round. Do you know why? Because A has been mentioned in the distance. So the initial velocity is U times N plus a half times F times T times N squared. This will give me 2 into B minus A is equal to UN plus Fn squared, equation 1. My acceleration is F, my time is N for the first case. For the second case, I'm going to cover a distance, C minus A. For C minus A.
Shepherd has 2 steps.
Pardon? Pardon? Hello? Hello?
on the last two steps.
Okay. On the last step, after substituting in this equation, have you got me how I've substituted here? I make the distance be this one. The time is n. N. Okay? Then the acceleration, I've let it be f. Now this I have. Oh, I've missed the 2 here. You multiply everything by a half to remove the half. So you multiply everything by 2. Remove the half. Okay? Then, for the second one, it will be c minus a. The initial velocity is still the same u. The time is 2n plus a half times the same acceleration f times 2n squared. This will give me c minus a is equal to 2un plus 2fn squared. This one was squared like this. Gave us 4. Okay? The 4 divided by the 2, you remain with the 2. That's how I come up with this equation. So this has given me equation 2.
Sure, isn't there 2 on C minus A?
This side, eh?
Yes.
No. You know why? It's because the 2 I have simplified it
No.
from here. Are you getting that?
Yes.
Yes. But one can do the same. You can cross multiply and then here you have 4. But the reason why I wanted this one to remain with 2u is because this is also 2un. I can easily eliminate them.
Okay.
Yes. Then lastly we have.
So why
Yes.
why 2n?
Why 2n?
So why do you have 2?
2un is common now in all equations. Because all of them were moving initially with the velocity u from point A, then the times went on changing. And the acceleration is uniform.
No, teacher, I'm asking.
Mm.
On the equation of on the second last equation,
Mm.
where have we got 2n?
The time between A and C is 2n. You see that? This time.
Okay, teacher.
Yes. Now, can you get for me the time between A and D? You yourself. Time between A and D. What is the time between A and D? Hello?
3n.
3n. Though I wanted that leader just talked to. Then the distance is what?
3n.
Then what is the distance?
D minus A.
Okay, D minus A is going to be equal to 3un plus a half times f times 3n squared. This will give me 2 into D minus A is equal to 6un plus 9fn squared. Equation 3. Now we have the 3 equations to solve simultaneously. 1, because this one is the same as this one, I can straight away say Roman 1 minus Roman 2. Eyes open. Shall have 2 into B minus A minus C minus A is going to be equal to a negative Fn squared. I'm dealing with this one minus this one is equal to this one minus this one, 0. Do you see the 0, all of you? Have you seen 2un minus 2un gives you 0?
Yes, teacher.
Yes.
Then fn squared minus 2fn squared will give me a negative fn what? Squared. Are we together on fn also?
Yes.
Okay. This Fn was 1, this Fn are 2. So 1 Fn squared minus 2 Fn squared, I'll get negative Fn squared. Now let's go back to my equations, brackets I began with. This is the 2b, all right? So I'll get 2b minus 2a. But here there is a minus and a minus inside. So the a becomes a what? A plus. So I'll get minus a. Minus what? C is equal to negative Fn what? Squared. The question wants us to first get the acceleration F. F is equal to 2b minus a minus c over negative n squared. When I divide through by the negative, I'll get F is equal to c plus a minus 2b, all is over n squared, which is this one. We are left with proving this upper one, which has a d in it. So we shall have to get this f and take it where we have a d. But before I take it, I can use this very one here. Fn squared is equal to a plus c minus 2b. Let me call it equation star. So I can put star in this equation. But before I put it there, let me first eliminate the un here. Look here, guys. 3 Roman 2.
Teacher, could you please go back a little bit?
On this one,
Equation star.
Yes.
What is it about?
equation star is coming from here. The negative has moved this way. I've divided everything by a negative. So 2b becomes a negative, a becomes a plus, c becomes a plus to confirm that relation. Is that better?
Yes, teacher.
Now, I want to eliminate this part so that I have a situation of d. But because this is 6un, I can multiply this equation 2 by 3. So that I call it 3 Roman 2 minus Roman 3. Do you know what it will become? It will become 3 c minus a minus 2 of d minus a is equal to 6un minus 6un a plus 6fn squared minus 9fn squared. I have multiplied this one by 3, the whole of it. By what? By 3. To create a 3c minus a, which is this one. A 3 times 2, which is 6. A 3 times 2, which is another 6. Then subtract off these ones. This whole bracket minus this one is this left-hand side. The 6un minus the 6un is what I've written. It's going to give us a 0. Then lastly, 6fn squared minus 9fn squared. If I can leave that part, do we have any questions there? With these numbers, you be patient. They test your algebra. They test your consistency. They test your simultaneous equations. Then they test your arithmetic. Remember, the first thing I said is to let acceleration be F. Had you let it be A, everything is wrong presentation. Because you can't have two A's which you can't distinguish. Any questions so far?
Excuse me, sir.
Yes, please.
I would like you to back up a little bit after us solving equations 1 and 2.
I'd like
After
to go
solving
back.
equations
I
1
don't know
and 2,
why.
yes. Here,
Yes. So last equation, sir.
this one,
Right there. Right there. Right there. So
here.
I don't know why we didn't. Yes. Yes. Yes.
Eh,
So I don't know why we didn't just equate it to equation what? Equation. Equation. This other equation.
this one,
Why is it? Are you getting me?
equation 3.
Yes, we just substitute this.
Eh, and you put here f, eh? Yes?
Exactly.
Why
Exactly.
didn't we put here f? Is that what you're asking?
Yes, yes.
Very good question. If you put here
Yes.
f in Roman 3, you will have a u. You have not yet solved. You see that? Yet this
Yes.
equation here has no u. It means you have to substitute f also in Roman 2 here, so that you design a new simultaneous equations with only u and u. Then you handle.
Okay, yeah.
But
I was
why
still
I'm
a bit
substituting
out.
fn square, what I want to do is to have fn. Now, because this one becomes 0. Do you see that? Is that 0?
Yes,
Then this one becomes,
it is.
this one becomes a minus 3 f
Negative 3n
n
squared.
squared. Is that true?
It is.
Now I can easily get this one and drop here. When I do so, I have eliminated the f, I have eliminated the u. But the other one you're saying is also right, but it is longer because you're going to substitute either in equation 2 and equation 1 to solve it simultaneously with equation 3. So to avoid that risk, I design fn squared, I eliminate the un in Roman 3, then because I want to introduce a d as per this equation, then I handle whatever I want. So this is 3c minus 3a minus 2d plus 2a is equal to minus 3fn squared. This a and this one, you get a minus a. So 3c minus 2d minus a is equal to a negative 3. Fn squared is what? A plus c minus 2b. Simplifying gives me 3c minus 2d minus a is equal to minus 3a minus 3c plus 6b. When the b comes over, let me see. This c gives me 6c minus 6b is going to give me 2d minus 2a. Finally, I'll have 6 into c minus b is equal to 2 into d minus a. Divide by 2, divide by 2. Hey, why am I writing capital? This is small letter. Giving me 3 into c minus b is equal to d minus a. Hashtag Wakanda, hence solution.
Excuse me, teacher.
Please go ahead.
Teacher, I'm requesting you to repeat for me from the start. My network had gone off.
This is
Cons of Farida.
Farida, okay. Farida, where did you stop? Even the equations, you don't have them.
I don't have, I just stopped on the sketch.
Yeah, it's quite. Why don't I send you the video?
Okay.
Yes.
Thank you, teacher.
Remind me my WhatsApp. I send you the video. My WhatsApp number is.
Okay.
I'll send
Like
it on the
send your
group.
WhatsApp number.
I'll send it on the group because I've seen some people have missed it.
Yes.
Yes.
Yeah. Okay, guys. So that's
Excuse
how
me.
that proof had to go. Any questions? Oh, and then I need to do one more number among other numbers you can choose, which you did and failed. But I have a
Sure,
question.
question.
Yes.
Can you please repeat from the third last step? No, the fourth. From 3c minus 2d minus a is equal to minus 3.
This one. Eh?
Yeah.
How I go to this one, right? Yes.
How you got? Yes.
Okay. This is negative 3c. Negative 3c comes and meets this 3c. It's a negative becomes a positivity to form a 6c. Are we together? 2d
Yes.
crosses over becomes a plus. Are we still fine? My negative
Yes.
a crosses over here becomes a plus, meets a negative 3a, becomes a minus of 2a.
Oh, yes.
Yes?
Yes.
The 6b
Yes.
was positive, has crossed over.
Yeah.
Okay. Any other?
Thank you.
Anytime.
Excuse me, teacher.
Yes, please.
Teacher, I've understood all this simplification you have done,
Mm.
but a little back here where I'm seeing 3 into equation 2 minus equation 3. I'm trying to beat my head around it, but I can't quite get what we're doing here.
Which one?
Yeah, where we have 3 into equation 2 minus equation 3.
Here.
Yes, I can't I don't know
What
what
was my intention,
we're
eh?
doing here.
I wanted to eliminate. I wanted to eliminate UN. And that's what I did here. Because I saw if I eliminate this one and this one, I would be left with Fn squared and Fn squared, and I would have introduced a D so that I can prove this part. That was the purpose of eliminating UN. But before you go to bed tonight to check on your algebra, I would rather you try out the other method you had proposed. Substitute here Fn squared, not just even F. Put in this one. Okay? Or this one.
Yes.
Put it here and also put it where? There. You have to put it in 2 equations. When you put it in 2 equations, you will have this UN. Then eliminate UN by still subtraction. You will come up with the same answer.
Okay. Hi.
Excuse me, teacher.
Yes, please.
Like before we move to any other question, we also had to find the initial velocity on that
They
same
asked
number.
for it.
Yes,
Where is the question?
down.
Oh, find also the initial what? Velocity. I get it now. Okay. Now we can do what this gentleman was asking for. Let me use C minus A is equal to 2UN plus 2Fn squared. So C minus A is equal to 2UN plus 2. Fn squared was what? A squared plus, A plus C minus 2B. 2UN is equal to C minus A minus 2 into A plus C minus 2B. This will give us C minus A minus 2A minus 2C plus 4B. I can eliminate U is equal to 4B minus 3A minus C, all is over 2N. And that becomes your answer. Don't forget Humphrey has answers at the end. You can always check.
Excuse me, sir.
Yes, please.
Excuse me, sir. Excuse me, sir. I was asking, can we use any of those equations of those different distances to get the initial velocity?
Yes, you use any other. Do you want me to show you the first one? Should I use equation 1? Let me use equation
Okay.
1. This 2B crosses over, gives us a 4B. This A crosses over, gives us a negative 3A. This C crosses over, gives us a minus C, is equal to 2UN. Hence Wakanda, same answer. Hope you see that you get the same answer. So in your free time,
Yes.
investigate equation 3. Yes, please.
Sure. I don't understand one thing. Okay. At the end of the question, they said prove that if the acceleration is uniform, d minus a is equal to 3c minus b, and that the acceleration is equal to c. Okay, that I don't stand there.
Hey, the question is saying prove d minus a is equal to that. The proof is here. And that the acceleration is equal to, also they're asking you to prove that the acceleration is that one. It is this one here. Find also the initial velocity. It is this one.
I thought they said prove that if the acceleration is uniform.
It's uniform, yes. F was
then,
uniform.
okay, wait.
When they say it is uniform,
Yes.
it means F is uniform in 1, F is the same in 2, F is the same in what? In 3.
In 3.
Yeah.
Yes. Okay, why is there d minus a is equal to 3c minus b in the middle there? I'm not connecting very well the sentences.
Here.
Yes.
That was the question. That was the first question to prove. That I could also prove it before even finding F. You could prove it before even finding F. What do? You eliminate. You eliminate Fn squared. Then retain Un in both. For example, I can say equation 3 minus 9 equation 1. Then I also say equation 2 minus twice equation 1. With these relations, I will eliminate f. I will eliminate fn squared. Then I'll remain with what? With un only. So I would solve for un and eliminate and get un in both equations and then equate un. It will induce what we have proved. Though it's longer.
Okay, thank you, teacher.
You're welcome. So guys, the rest of the numbers, keep trying them out. Send them in my box. I'll present the solutions on the group. For those of you who have emails, my email is this: lhmzer@gmail.com. Then the rest we shall meet on WhatsApp, because next lesson I should be in position to introduce graphical numbers. But these other ones of just equations and solving, those ones you can now inbox them to me and I take a look in case one of them challenges you. I'm going to post the video. Those who want to go over it again can go over it again. All right. Any other questions?
I'm still not understand.
Why?
Why the question the previous person was saying about where we had to subtract 3 Roman 2 minus Roman 3 to prove whether the acceleration is uniform. Okay, that statement proves that if the acceleration is uniform.
Yeah. You hear this question. Prove that he is your brother if your dad and mother are the same. What is the question?
Yeah.
Prove that he's your brother if your dad and mother are the same. What does it mean? I'm saying the question is prove that he is your brother given that your father and mother are the same, or if your father and mother are the same. What does the question want? What do you think the question would like for that question? Would like you to handle? The question in that case would like you to tell us, is he really your brother? Or what can you do to show that he's yours? Your brother. Given that your father and mother is the same. You have the same father with him and mother. Prove that he's your brother. 1, you can't marry him. 2, you can't date him. 3, you can't give birth for him. 4, you stay with him.
So
Now, this question was saying, prove that. Prove that if we know, if means we already know, that if the acceleration is uniform, so we already know that the acceleration is uniform. If the acceleration is uniform, yes, it is uniform. We already know that. Show us that d minus a is equal to 3 into c minus b. After that, the acceleration, we know it's uniform, but we don't know it. And that the acceleration is equal to, and confirm, prove to us that the acceleration is c plus a minus 2b out of n squared. We knew the acceleration was uniform. For example, you know a pregnant woman. We know that someone is pregnant is going to give birth. We are sure she's pregnant, but we do not know the child she's giving birth to. Most girls and ladies hide their pregnancies in terms of sex. Yeah? They normally reflect them on baby showers. They hide, but we already know they are pregnant and they are going to give birth. But we don't know. So what if she says, prove that she's going to give birth to a boy? The only way you can do that is either go for a scan or wait for the baby. No, after that, telling you to prove that the acceleration is that, which acceleration we had already known that it was uniform. We did not know it, but we knew it was uniform. Meaning every equation has to have the same acceleration. Find also the initial velocity. That go ahead and get the initial what? Velocity. It means we knew it had the initial velocity also, but we don't know what exactly it is. So go ahead and also find the what? The initial velocity. That is the interpretation I can give as a highlight for that number. I don't know whether I've tried to make myself clear.
Yeah, I've got it.
Okay, please. Any other guys? Some guys are coming now. Okay, it's 9, time for the news. I also have to go and park my car. I came rushing, I didn't even park the car. So let's stop there. I will send the video for those of who have missed and my friends would like to review. Yeah. Okay, so hope you have a very good night. But please try the numbers. Math has no shortcut apart from trying the numbers. And remember, COVID is real. Any other person you know who is sick or you've heard of who is sick, people are lying to you, they are suffering from COVID. And it is really killing them. So guys, be mindful, stay healthy, stay safe. If you have to go for a wedding, sanitize, mask yourself entirely. If Pin is putting on gloves, do so. If you have to go for burial, the same thing. Wherever you have to go in a crowd, please do maintain the SOPs. Okay, with that, I would like to thank you for your attendance and for showing up for this lesson. May you keep the spirit till senior 6. Okay, have a lovely night.
Good night.
Good night, you too.
Likewise, teach.